Yo, okay, today I'm going to be showing you guys how to do problem number 16 from homework number 1. It's pretty straightforward. So the question's asking us, what is the net electric force on charge A? And we know that net electric force is equal to the sum of the other forces acting on that specific charge. So we're going to say F net is equal to the force of B acting on A plus the force of C acting on A. Then we know that force is equal to K, charge 1, charge 2, all over the distance squared. So in this problem, we already are given pretty much everything we need to know. K is a constant. We have the charge of each particle, and then we have the distance from A to B, and then the distance from A to C. So for example, this is wrong. For example, the distance from A to C is going to be 1 centimeter, 2 centimeters. So we're going to call that R2. Alright, so now we just basically plug everything into these two equations. So F of B on A is equal to K, which is 9.0 times 10 to the 9th newtons meters squared over coulomb squared. Now we have to multiply by our charges. Charge 1 we'll call A, which is 1 nanocoulomb. And charge 2 we're going to call B, which is negative 1 nanocoulombs. And we're going to divide by the distance from A to B, because that's what we're calculating, is our force of B on A, which is just 1.0 centimeters. And we square it. Then we have to, I'm going to continue on the bottom, by the way. I don't have room here. But we have to cancel all our units, because we don't deal with nanocoulombs or centimeters. So we're just going to convert them. And 1 coulomb is equal to 10 to the 9th nanocoulombs. All our units cancel. And we're left with just newtons. Now we calculate everything, and we end up with 8.99 times 10 to the 9th newtons. Now we got to do the same thing, but for charge C, the force of C on A. Again, it's equal to K, which is 9.0 times 10 to the 9th newtons meters squared over coulomb squared, times our charges, which again, A is 1.0 nanocoulombs, and C is 4.0 nanocoulombs this time. And again, our distance from A to C is going to be 2.0 centimeters, again squared. Cancel units. And again, we end up with the same number, 8.99 times 10 to the 9th newtons. So normally we just plug everything into this equation here, but we got to think about this a little bit. We know that a negative charge is actually acting in this direction, and a positive charge is acting in this direction. So now we have two equal and opposite charges. So we're going to say that charge, or the force of B on A, is actually negative. So we're going to write that out like this. And then we're going to add it to the force of C on A, which is positive because it acts to the left. So again, charge C is acting towards charge A. We have an actual force acting on A that way, whereas B is pulling away from charge A. And now we add these together and we end up with 0 newtons. So charge A experiences a net force of 0 newtons. Now we just gotta hope that the midterm's this easy. Thanks for listening, and that's it for this.